Hi, my name is Harley Fuller and this is my Lab 2 video report. For the agenda today, we'll be discussing the problem that we have successfully modeled, showing some of the experiment performed and its results, going through calculations that help explain the reason behind our experimental results, and how we can code a model on computer programming. To introduce this experiment, I will go over the basic goals, materials, and procedure that was used. Our goal is to explore the fundamental physics principle of electric force and charged objects. We will be utilizing basic household objects and creating a charge on them to see how well they interact with other neutral, positive, and negatively charged objects. The materials used in this experiment consist of tape, a ruler, a flat surface, and yourself. To begin, I put down a piece of base tape where the next piece of tape will be placed on top of. The new tape will be the object that we are giving a charge, and this is done by quickly ripping the tape off of the base tape. To ensure it was done correctly, we must test the charged tape. This is done by hanging the tape off the side of the flat surface and checking to see if it interacts with our hands, which are neutrally charged. We then can start experimenting with other charges. Next, we create a second charged piece of tape to see how the two charged tapes interact with each other. When the two tapes come close together, they push each other away, which tells us that both pieces of tape have the same charge. In the lab document, we are told we can create a negatively charged pin by rubbing it on a piece of cloth or, more readily available, our own hair. When placing this pin near the charged tape, we see that it also repels. This tells us that the tape is negatively charged because it repels when presented another negative charge. Now that we know the charge of the tape, we can move on to another experiment, which I will show you on the next slide. For this part of the experiment, we will need to add two similarly sized books to our material list. We will take our first charged tape and hang it across the two books. It will need to be hanging down in the center, similar to a rope bridge. This is essential for this part of the experiment as we will be making the tape appear to float. Since we know the two pieces of tape have like charges by the physics property of electric force, they will repel. We will then take our second piece of charged tape and place it near the bottom of the first charged tape. The closer the second tape gets to the first one, the higher the first one will rise, with a noticeable change around 2 centimeters of separation distance. This part of the experiment is very important as it is what we will be modeling with the computer program. This differs from the last lab as we are now treating the charges as being distributed across the entirety of the tape instead of being a single point charge. Now I would like to show some calculations behind this experiment. On the top tape, we know the two forces acting on it are gravity and the electric force from the bottom tape charges. By Newton's third law, we know that objects in equilibrium have equal and opposite forces. This helps us find the magnitude of the electric force since we can easily calculate the force from gravity. After using these equations to find the force of gravity, I negated it as shown in the third point to represent the electric force. This came out to be 0.00175 kilogram meters per second squared. To compare to treating it as a distributed charge, we sum all of the single point charges using the formula pictured. To distribute this force, we would adjust this equation by taking our electric force and dividing it by n, the number of charges we want. For question 1, we ignore air resistance in this lab. Because the tape stabilizes out, it is no longer moving and air resistance is not applicable. We also assume that the charge is uniform throughout the piece of tape. If it is not, our code would inaccurately compute the electric force. In this lab, we no longer treat this tape as if it was a point charge. We are instead distributing the charge over the entirety of the tape. On to the last part of our agenda, I would like to discuss the coding aspect of this lab. The code takes the tape and distributes the force over n points. The greater the value of n, the more accurate our answer is. With this, I adjusted the starter code to show the forces of the bottom tape onto the top tape, and vice versa. This then prints out the magnitude of the electric force and gravitational force. There are arrows to show the different forces and their magnitudes acting on the two tapes. To answer our second question, this gave me an electric force of 1.592 e to the negative 3 newtons and a gravitational force of 1.599 e to the negative 3 newtons. In conclusion, modeling the charge distributed over the whole tape is slightly more accurate than modeling it as a point charge. This helps us find more accurate answers instead of just approximating them. This concludes my Lab 2 video report. Thank you for watching.